Hello everybody and welcome. Today we will be solving problems on motion in one dimension. Okay, so let's start. Question number 1. It says here that a race car starting from rest accelerates uniformly at a rate of 4.9 meters per second square. What is the car's speed after it has traveled 200 meters? Okay, as we agreed in the previous videos, to deal with these types of questions, I think the best option to do here, or the best approach, is that you start by writing the 4 equations. Do I have to write the 4 equations? Well, yes, as I mentioned before at the beginning, always write the 4 equations. It will help your muscle memory remember these equations. So if you were in the exam and you can't remember any question, your muscle memory will kick in and it will help you. Second of all, you will reach a point that by reading the question, you will know which equation to use. We were saying that a race car starts to accelerate uniformly, but it's important to read that it says it started from rest, so we know that v initial x is equal to 0. Now, and it accelerates at a rate of 4.9, so it's clear that the acceleration is equal to 4.9 meters per second square. Now, what is the car speed after it had traveled 200 meters? So the displacement delta x is equal to 200. Now, thinking of it, let's start with the first equation. The first equation said that v final x is equal to v initial x plus a multiplied by t. Do we have v final x? No, we do not have v final x. Do we have v initial x? Yes, we do. Do we have the acceleration? Yes. Do we have time? We do not. So, two unknowns, we can't solve this problem. Second equation says v final x squared, which is what we are looking for, is equal to v initial x squared plus 2a delta x. And it's clear that this is the unknown. And we have this number here, we have the acceleration, and we have the change in displacement. So quickly, v final x squared is equal to v initial x, which is 0 squared, plus 2 multiplied by the acceleration, which is 4.9, multiplied by the displacement, which is equal to 200. So if we plug in the numbers, this will take us to that v final x squared is equal to 1960. We will take square root for both sides and we will get that v final x is equal to 44.3 meters per second. It is choice C. Next question. It says here that a bicycle starts from rest. So again, we have v initial x is equal to 0 and it accelerates at a rate of 4 meters per second square. How far will it travel during the first 3 seconds? Okay, so this time we have time equal to 3 and it's asking for delta x. Delta x is the unknown. So let's start with the first equation. V final x. Do we know v final x? No, it's an unknown. Do we have v initial x? Yes, we do. Do we have the acceleration? Yes, we do. Do we have the time? Yes, we do. Okay, now we can solve this equation and find v final x. But will it serve our purpose? At the moment, no. V final x, it's unknown. V initial x, we have it. Delta a, we have it. And delta x, we do not have it. So we have two unknowns. Let's try this equation. Delta x, it's unknown and it's what we are looking for. V initial x, we have it. The time, we have it. The acceleration, we have it. So the best solution or the best choice is equation 3. We're going to say that delta x is equal to v initial x t plus half a t squared. Now, v initial x is equal to 0 multiplied by time, which is 3, it doesn't matter, plus half multiplied by the acceleration, which is 4, multiplied by 3. Do not forget the squared. So it's 3 squared. In other words, the answer will be equal to 18 meters. So choice B. Question 3. A skydiver has been in the air long enough to be falling at a constant terminal speed of 50 meters per second. Okay? How much farther will the skydiver fall in the next 2 seconds? Now, in these types of questions, I want you to concentrate. When it mentions that we have a constant speed, this means that the acceleration is 0. Now, when the acceleration is 0, there is no need to start with these equations. But if you forget about this information and use one of these equations and you replace acceleration with 0, you'll also get a correct answer. But no need to complicate things. We can just go simply with the equation saying that velocity is equal to displacement over time. Okay? Now, what is he looking for? He's looking for the distance. How much farther will the skydiver fall? So he's asking about the distance or the displacement, which is delta d. We have the velocity and we have the time. So we can say that simply delta d is equal to v multiplied by t Then we have the speed v multiplied by t, which is time, which is 2. And the answer is 100 meters. The displacement will be equal to 100, so the answer is D. Next question. An object is moving in a straight line with an equal to 12 meters per second. When it begins to slow down with a constant acceleration having the magnitude equal to 5 meters per second. But it says here that it's slowing down. Okay, so concentrate here. It's slowing down at a rate equal to 5 meters per second square. How long will it take for the instantaneous speed to reach to 2 meters per second? So we know here that v initial x is equal to 12, okay, which is clear. Now v final x, it's clear here that it's going to be equal to 2 meters per second. What about the acceleration? Well, actually the acceleration, it's going to be equal to -5. Why are we going to use the minus sign here? Well, it says that it's slowing down. And we will get used to these types of questions. So from now on, when you see the word slowing down, you will assume that the acceleration has a negative value, okay? And because it is slowing down, because it's a vector quantity, so the negative sign will do, okay? So how long, it's asking for the time, which is the unknown, will it take for its speed to become equal to 2. Now, let's look at the choices right here. Which equation is the best? V final x, we have it. V initial x, we have it. The acceleration, we have it. But t is unknown, so it's clear that we will be using the first equation here. V final x is equal to 2. This is equal to v initial x, which is equal to 12, plus the acceleration -5 multiplied by t, which is time, okay? Now we will subtract 12 from both sides, and we will get that -10 is equal to -5 multiplied by the time. This is clearly giving us that t is equal to 2 seconds. So if we look at the choices, the answer here is 2 seconds. Next question. A ball is held out at the 3rd floor, okay? So it's held out at the 3rd floor window, and it's released from rest 9 meters above the ground, okay? Now, if air resistance is negligible, which of the following is the best estimate of time it takes for the ball to fall to the ground, okay? Now, this time we are talking about vertical movement. So we will replace Vx with y, and we will replace delta x with delta y, and we will replace a with -g, okay? So the equations are the same, but we are replacing a with -g, and every x is being replaced with y, okay? So let's try to draw it. This is the building, this is our building, and we are holding a ball out at a height 9 meters above the ground, okay? So this is our ball, it's falling towards the ground, okay? Now, which of the following is the best estimate of time? What is unknown here is the time, so the time here is unknown. What about the acceleration? Well, the acceleration, nobody has to give us the acceleration because we know it's g and it's equal to 9.8 meters per second square, okay? So which equation should we be using? We will not forget that it mentioned here in the question that a ball is held out at the 3rd floor, so it is not moving yet. So we can say that Vy initial is equal to 0, okay? Vy initial is equal to 0. So let's look at these equations here. Which equation should we start with? Do we have the final speed? No, we do not have it. Do we have the initial speed? Yes, we do. Do we have the acceleration? Yes, which is g. And do we have the time? No, it's unknown, so we can't use this equation. Let's see this equation. V final x is equal to v initial x plus 2a delta x. We do not have v final x. We do have v initial. We have the acceleration, and we have delta x, or the height. In our case, it's delta y. We can use this equation, but it will give us the final speed, and we're not looking for the final speed. We're looking for the time. Now let's look at this equation here. Delta x. Here we have the displacement. Do we have the displacement? Yes, it's 9. Do we have v initial x? Yes, we do. Do we have the time? We don't. We're looking for the time. And do we have the acceleration? Yes, it's g. And do we have the time? No, we're looking for it. So our best choice is this equation, equation 3. So let's write it in y notation. So delta y is equal to v initial yt minus half gt squared, okay? Now, it's important to keep in mind that the object is going downwards, and I know that delta y is the displacement, and displacement is a vector, okay? So in this case, since it's going downward, we're going to use a negative sign to indicate that it's going downward. So instead of 9, I'm going to say negative 9 is equal to v initial, it's 0 multiplied by t, minus half multiplied by g, which is equal to 9.8, multiplied by the time squared, which is unknown. We do not know the time, okay? So negative 9 is equal to negative 4.9 multiplied by t squared. So if we divide both sides by 4.9, we will get that t squared is equal to 1.83, and if we take the square root for both sides, we will get that t is equal to, let's take the square root here and here, we will find that t is equal to 1.35 seconds. So time here is equal to 1.35 seconds. Let's look at our choices right here. We can find that the closest answer is C. It's the closest answer to the 1.3. So the answer is C. Next question. A person drops a stone from the top of the well and it hits the water 3 seconds later. The distance from the top of the well to the water level is most nearly, okay? So let's look at the input we have here. A person drops a stone from the top of a well. So Vy initial is equal to 0 because it's not moving yet. And it hits the water 3 seconds later. Okay, so the distance from the top of the well to the water level is most nearly what? Now let's look at our choices. Which equation of the following should we be using? Do we have the final velocity? No, we don't. Do we have the initial velocity? Yes, we do. Do you have the acceleration and time? Yes, we do. But we are not looking for the final velocity. Let's try with equation 3. Let's jump directly to equation 3. The displacement, do we need the displacement? Yes, it's asking about the displacement. Do we have the initial velocity? Yes. Do we have the time? Yes. Do we have the acceleration? Yes, we do. And we also have the time here. So we're going with this equation. Delta y, again, the same equation, is equal to v y initial t minus half g t squared. And so since we're looking for delta y, we'll just plug in the numbers directly. 0 minus half multiplied by 9.8 multiplied by 3 squared, which is equal to, then delta y here is equal to 44.1 meters. Okay, but it will be in the negative sign. Why is that? Because as we mentioned, it's a displacement and the object is going downward, so it will take a negative sign. Let's see our choices. The closest answer will be C, which is 45 meters. Next question.